Dr. Prakash Chavan to join. I think he has not yet joined. Yeah, we are waiting for him to join, and we will start the lecture as soon as he is available.
Good morning, madam. Is it audible?
Dr. Prakash?
Yes, yes, yes.
Yeah. So I'm happy that you have joined on time, and we will start now. A very good morning to you all, and today we bring to you the monthly lecture series once again, the October lecture series. Under the able guidance of DGCSIR and Dr. Vibha Malhotra Sahane, our head IPU, the monthly lecture series was started in the month of April on the occasion of WIPO Day, and we started the first lecture in the month of 2023. Now, I, along with my colleagues, Dr. Lipika Patnaik and Ms. Ajita Agarwal, will bring to you the October lecture from Dr. Prakash C. Chavan, Chief Scientist, Csir-Cimfr, Dhanbad. Before we start with the lecture, I will briefly introduce Dr. Prakash Chavan. Dr. Chavan, before taking his lecture, followed by the question answer session. Dr. Prakash Chavan is a chief scientist at Csir-Cimfr, Dhanbad. He started his career at Csir-Cimfr and he will have to in
2002.
2002. Yeah, that is what I was looking for. I did not get the yeah. So he's joined in 2002 after completing his BE Chemical Engineering and PhD. He did during the course of his tenure in Dhanbad, and it was from ISM Dhanbad, which is currently IIT Dhanbad. Yeah,
yes.
Indian. Yeah. So his areas of interest are coal biomass gasification and syngas utilization, amongst other, and hazardous chemical and waste incineration system, on which the current topic is also based. He is a member of Technical Standing Committee Group for Indian Coal Gasification Mission under NITI Aayog, and representing Csir-Cimfr at various committees of NITI Aayog. He is life member of Indian Institute of Mineral Engineers and life member of Mining Engineers Association of India. He has 37 publications, 4 patents and 6 copyrights to his credit. Now I would like to invite Dr. Chavan to give his presentation and lecture.
Thank you, madam.
Please, you are welcome.
Thanks to all the members for showing interest and attending this particular we can say our experience in the recent past 3-4 years related to development of gasification facility at Csir-Cimfr. I'm just sharing my presentation. Is it visible?
Yes, it is visible.
Thank you. Thank you. So I'm just sharing our experience related to our journey during development of fluidized bed gasification pilot plant at Csir-Cimfr. It was initiated in the year 2017. We got this particular project and we completed installation and dedication of this facility to nation in December 2020. We can say in completely in the Corona period. Basic thought behind this particular development and driving force was Government of India's mission and targets to minimize the imports related to, say, whether it is a petroleum crude or natural gas or petroleum products, which definitely we are maximum amount we are importing from several countries, and still if we think we have tremendous potential to generate all these requirements through available resources, mainly coal and definitely to some extent from biomass type of resources also. So with this particular aspect, Government of India has initiated very uh, big program related to in the area of clean coal technologies to make the country Atmanirbhar in this particular area. And Honorable Prime Minister has given target to utilize 100 million metric ton of coal per annum. Its utilization through gasification to fulfill all these requirements. So this was the driving force behind this particular thought. And once we generate or convert coal to syngas, we can fulfill most of the requirements. We can say several requirements, right? From generation of fertilizers, chemicals, liquid fuels, hydrogen generation for refineries and other applications, several thermal applications, and definitely power generation also. So once we generate syngas, it is very easy to fulfill all other requirements. Even with available facilities, we need not to go for much switch over in the or develop other utilization facilities also, except gasification island. This is just figures related to coal reserves in India. We have sufficient reserves at least for another 30 years, we can say. Similarly, biomass resources also available everywhere. Only thing is it is in distributed form, but definitely we can initiate from agro industries at least where we can get certain amount of biomass in readily available form. So with this particular background, Niti Aayog initiated this particular program, we can say methanol economy mission program. And in September 2015, first meeting was conducted at INSA building in New Delhi, where most of the players in the area of, say, solid fuel utilization through gasification, combustion, and other downstream areas, including conversion of syngas to variety of products. Most of the players from all over India were participated in this particular first meeting. Then they also conducted one international seminar at Manekshaw Center in New Delhi in September 2016. In between, there was several meetings and brainstorming sessions also to come to certain conclusion. And this particular seminar was targeted specifically on methanol economy through gasification. And ultimately, they formed 5 task forces related to coal gasification based syngas generation, then biomass-based syngas generation, syngas for utilization for methanol and DME. Similarly, utilization of methanol DM-based engines, uh, if any conversion or modification, all those things. And then public awareness related activities to utilize methanol for to fulfill variety of requirements. So, Cimfr was part of first task force for generation of syngas through basically coal gasification. And this particular task force conducted more than 35 brainstorming sessions and meetings to arrive to the specific roadmap and targets through this particular program. During these brainstorming sessions, we conducted a review of most of the available gasification technologies, commercially available, readily available, we can say, and also evaluated other syngas utilization technologies also. And ultimately, we arrived to concrete program out of this particular indigenous gasifier development was also one of the major um, target, and it was a 3-stage program. So in the left side, we can say one identified program was utilization of readily available technologies to fulfill certain requirements, again through gasification, but certain limitations are there. We will not go into details about those, why these readily available gasifiers have limitations in view of available coal resource in India. But our target was development of indigenous gasifier. Fortunately, uh, we were having certain background in the area of gasification since last 2 decades, and other certain institutions, organizations in India also. So it was a development of, first target was development of pilot scale facilities, then demo scale facilities, and then after comparison with commercially available technologies, then final implementation, commercial scale implementation at different locations, different pithead locations, we can say, to fulfill the target of utilization of 100 million metric ton of coal through gasification to fulfill above mentioned requirements. At that stage, we were having in our country, we were having certain little but experience, we can say, but not that much attractive. Most of the projects were executed in 70s and 80s, but most of them were closed within just 5 to 10 years experience only, getting feedback. Those there were certain issues related to lack of understanding of the feedstock, and which is definitely linked with the how to resolve the operational problems and to improve the, say, efficiency, to make it more feasible, to make it more economically attractive. So that's why, due to these lacking areas, ultimately those programs were stopped in within 5 to 10 years time span only. And if we see the current scenario in India, two big capacity projects are there, but again with imported technologies. One is at in Odisha at Jindal Steel and Power Limited, Angul. They are generating syngas using Lurgi gasifier, and they are utilizing for steel making through DRI process. And another important project is by Reliance, but that is not through utilization of coal. It is with petcoke, and they are utilizing generated petcoke for variety of applications. One project is in pipeline at Talcher. It is Talcher Fertilizer Limited. We are expecting its installation by next year, 2024. And other few small scale gasifiers are there, producer type of, we can say, crude gasifiers to fulfill certain thermal applications in variety of industries. And at CSIR level, we can say we were having one air-blown gasifier, which we have developed in 2009 at Csir-Cimfr. And we have tested variety of feedstocks, including coal, biomass, and their blends to generate syngas. But it was since it was an air-blown gasifier, so generated syngas was lean syngas, not suitable for generation of say methanol or chemicals, fertilizers. So necessity was to uh, uh, develop oxy-blown gasifier, not air-blown was not sufficient. So, but at least we get certain experience and confidence with this particular facility. And at that stage, we were only, but this was the certain aspects which we were knowing related to gasification. Yes, definitely chemistry behind the gasification as well as certain engineering aspects we were knowing. Other institutions, or we can say that type of knowledge was only available. But when we see the important aspect related to operational issues, its feasibility, and since it is a very complicated phenomena consisting of highly complex hydrodynamics, uh, several parallel reactions, and highly heterogeneous feedstock. So proper understanding of feedstock, specifically mineral matter behavior inside the any type of gasifier is very much essential. And this was the particular issue in failure of gasifiers in past in India also. And even people are facing still issues mainly due to this particular aspect. So thorough understanding of the feedstock and mineral matter means ash inside the gasifier uh, is very much essential to overcome all the challenges and to make the process easy to operate for any industry and economically feasible also. So with this background, Csir-Cimfr decided a program consisting of three major targets. One, development of center of excellence with consisting of all the facilities required for gasification, uh, for gasification potential mapping, means understanding its behavior of the fuel and its relevance with say matching gasifier or its behavior inside the gasifier, its performance inside the gasifier. So all the facilities was necessary. The next target was development of fluidized bed gasifier, definitely oxy-blown now to fulfill the requirements of targeted products, methanol, fertilizer, and all those type of things where we definitely require concentrated syngas. And then our next target was development of syngas to methanol pilot plant also. So with these targets, we developed center of excellence consisting of most of the facilities. So presently, this particular syngas to methanol pilot plant development is still pending, along with certain advanced other gasifier which we have targeted. Uh, and most of the other things are ready. This is the Center of Excellence for Gasification at Csir-Cimfr Digwadi campus. And with these particular targets and facilities, we chalked out the three-pronged gasification program at Csir-Cimfr, mainly consisting of understanding of feedstock. Definitely, it is essential. Then development of suitable technology, that is fluidized bed gasification technology, and definitely operational philosophy, because standard of operating procedure SOP cannot be utilized for gasification like phenomena, because every time when we feed any feedstock, every day it will be different, characteristics will be different. So SOP will change with feedstock characteristics. So we can call it as a operational philosophy. It is a, we can say SOP, but definitely linked with the characteristics of the feedstock. So these three aspects were essential, and we developed the characterization matrix in relation with the gasification, where several characterization tests were developed at our department research group, and we made a characterization matrix, complete matrix, to address all the aspects of gasification, to understand entirely complete phenomena, ash behavior, and all those things, which is very much essential for gasification. With this understanding, even we conducted uh, uh, one important activity jointly with Coal India, where we analyzed uh, gasification related characteristics from two subsidiaries of Coal India, MCL, three subsidiaries, MCL, CCL, and ECL, for thorough analysis from around 36 to 40 identified mines by Coal India on the basis of its availability or feedstock availability for another around 20 years. And all those were non-linked mines for any ongoing project. And this particular report consisting of complete characterization and suggestions towards selection of gasifier and its behavior inside the particular gasifier. This report, thorough report, was submitted to Niti Aayog for further roadmaps and decision makings. Then next target, parallelly we executed, it is a development of 1.5 TPD oxychlone pressurized fluidized bed gasifier. Initially, target was to develop oxygen enriched PABG, because we were not confident about oxyblown, whether we can develop or not, because we were having only experience in air-blown gasification. But after systematic development, definitely we achieved its operation in oxyblown, completely oxyblown mode also. Total budget was 324 lakhs. Out of that, capital was 287 lakhs, and all these design related aspects were in CSR simple scope, including basic design of all the components, the gasifier cyclone and its preparatory lining. Important part is the distributor, which is we can say call as a heart of the gasifier. So its detailed design was in simple scope, including air plenum, then sizing of all other components, including pretty vessels, ash vessels, quench column, piping, selection specifications for all the instrumentation part, all the utilities, and other supporting components also. And definitely operational philosophy for gasification. That was only Cimfr was the agency to conduct all these type of things. And fabrication, installation, commissioning was in vendor scope. So we initiated the tendering process and for getting this particular facility. But it was very difficult to get potential vendors at Dhanbad due to definitely due to locational disadvantages, because most of the chemical industries are in western zone of India, and service providers for fabrication, for instrumentation, uh, all the related things, it was very difficult to get here. Also, quotes were on very higher side from experienced vendors. So getting L1 was very difficult. And definitely to convey properly our exact requirement to the vendors, it was very much essential to get perfect facility. So we conducted a series of pre-bid conferences and site visits to make them understand our requirements clearly. In this way, we conducted 2 attempts of tendering, and in second attempt, we got successfully L1 firm. Definitely, certain aspects were unattractive for them, including payment terms, and certain components was, since it is a pilot plant, so capacity was very low. These components like say feeder, extractor, all those are not standard items. So tailor-made fabrication of single or one or two piece of this type of item was very difficult. Nobody was ready to fabricate these type of items. So ultimately we got successfully L1 firm, that is Messrs. Amar Equipment from Mumbai, and order was placed in September, October months in 2018 for development, installation, fabrication, installation, and commissioning of this targeted facility. Thus, fabrication was smoothly. We were conducting at their workshop. We were visiting frequently to support them, to analyze the monitoring the work, fabrication work at their workshop, whether it is in right direction, because solid handling requires certain precautions to avoid the smooth flow, smooth operation of the solids inside the particular device. And another challenge was, since target was to install this facility in the readily available existing building at Csir-Cimfr, where we were not having sufficient space between targeted plant and roof of the existing building. So this was also one of the challenge. Thus, we got most of the components delivered between December 2019 to February 20, fortunately. And we initiated erection of the skid and mounting of certain components during this, after this particular period. But unfortunately, government imposed lockdown due to COVID-19 situation from 25th March, and everything was stopped. Fortunately, installation team was at our site with limited manpower at that time, required for initial activities, installation of skid and certain fabrication related, piping related activities, we can say, along with refractory lining team from their sub vendor. So only these two teams were there at that time. So during lockdown, definitely activities were halted for a couple of weeks. But with permission from authorities and precautionary measures, we again reinitiated these activities. But we needed to manage all these activities with available resources. So we involved refractory lining team also for fabrication activities with their permission. And we continued fabrication installation related activities. Definitely we were facing issues related to getting tools, tackles required for fabrication and installation related activities at site for piping, including very small hindrances like getting building rods, gas cylinders for metal cutting and all those things, even consumables like pipes, fittings, and smaller instruments, because entire market was closed during that period. But with available resources and available facilities, we were conducting activities. We we are having certain facilities at Csir-Cimfr also, including workshop. So our engineering service departments help a lot for execution of this particular activity. These are certain photographs of the installation related programs right from the zero date. And among these, here we can see the in situ casting of refractory inside the gasifier was very, we can say, toughest activity, because gasifier shell diameter is just 0.7 meter, and it was necessary to cast the refractory in different stages by entering the expert person inside that particular shell, having diameter 0.7 meter and height around 5 meter. So even we needed to provide air for breathing through the through pipeline. In this way, we conducted. Actually, this is the practice for putting the refractory lining inside any type of furnace. But since it was very small plant with smaller diameter, so we faced lot of problems. For big capacity plants, they can make easily. They can install refractory lining or in situ casting very easily. Since the diameter was very short, very minimum, so we faced lot of problems. Uh, in this way, fabrication we continued, and we were facing lot of problems because this particular team was here away from their family for several months during lockdown. Their family was facing several issues there. They were staying here for at least for 6-7 months, uh, and it was very difficult to bring here new team or to even persons required for further activities, instrumentation, PLC SCADA, automation for other bought out installation of bought out items. They were taking help from their sub vendors, and available team was only installing most of the components with telephonic or video conferencing mode. They were staying inside the colony, so they were allowed to work here, but it was very difficult to get any person because very stringent rules were regulations were there, quarantine related, travel related. So we prepared a thorough monitoring document, Excel based document where more than 983 activities and components were there related to this particular facility. We were reporting them through this particular Excel based sheet where we were showing with different colors what is completed, what is ongoing, what is pending, which material is available, which is not available. Everything we were reporting on daily basis. We were interacting with their headquarters on frequently, and weekly we were conducting meeting with them through video conferencing. We were giving pressure to them to conduct all this, to provide all the required pending items as well as to provide expert persons for this particular execution. And thus we successfully completed installation and commissioning activities by November 2020. This was the facility consisting of all the modules. And then this facility was dedicated to the nation on 17th November 2020 by Honorable Minister Science and Technology at that time. CSRDG also visited within that time span, and NITI Aayog member Dr. Saraswat sir, who was looking after, who was monitoring all these activities since it was under the mission mode program. So he also visited and encouraged us for this particular achievement and to conduct further programs. Capacity of this particular developed capacity facility is 1.5 tons per day. Fuel feed rate, again, it varies with type of feedstock. For biomass, it is little but on lower side. Operating temperature is in the range up to, we can say 1050 we can go, and pressure up to 10 bar. So we tested variety of feedstocks, coal from different location, MCL, CCL, definitely high ash coal, and we conducted cumulative operation till date, including biomass rice husk specifically, for more than 200 hours till date. And syngas composition, what we achieved is very attractive for downstream applications. CO hydrogen is in the range of 25 to 30%, which is quite comparable with commercially available gasifiers. Carbon conversion is on little but lower side for coal when we compare it with other high temperature gasifiers, but still it is acceptable for industries when we have some ash utilization techniques. Ultimately, we filed a patent and taken copyright for this particular development. This is a typical graphical representation of the experiment what we have conducted. This is for one single experiment only. And this is the syngas composition throughout the run. In summarized way, we can say achievements are now we are generating completely tar-free syngas for any downstream application. We have overcome all the operational problems, including agglomeration type of things, with definitely with high ash containing feedstock. We have successfully developed operational philosophy linked with their characteristics of a particular feedstock. And now basic engineering data is available for development of demo scale facility also. Mass energy balance, risk and failure analysis, protocols related to startup, shutdown, maintenance, the breakdown maintenance, routine maintenance, everything is now available with us for each and every module, each and every component of the plant. And definitely proper understanding related to feed characteristics and its performance inside the gasifier. That entire package is available. And the next target is the development of definitely demo scale facility on the basis of these achievements. And outcome from this, yes, it is a pilot scale technology is readily available now with us, which can be taken forward. Complete thorough physicochemical characterization matrix linked with the its behavior and performance inside the particular gasifier. We have two Indian patents, one for this PABC gasifier, another for associated activity development of TGR. And even we have two PCT patents also for this. 4 copyrights are there. More than 10 publications and 2 book chapters are. Several students have completed MTech projects. One PhD already completed, 4 are ongoing. And several students have completed their internship and training programs in this particular facility from nearby engineering colleges, from other institutions, including ICT Mumbai, IIT Jammu, BIT Mishra, and several engineering colleges from this region. We have made presentations for this development at several ministries, including Ministry of Coal, Steel, Chemicals and Fertilizer, Niti Aayog, various international conferences, academic institutions. We have MOU with now several institutions for collaborative programs, and also Coal India in resource group. And several engineering students, domain experts, government officials, and people from industries have visited this facility. Now, definitely next target is development of demo plant, but joint venture is required with engineering houses, then industrial partners and other CSIR institutions also for this particular activity. I have listed certain R&D areas for further refinement to make these processes, this particular development more feasible, more attractive, economically attractive. So, further understanding related to mineral matter, handling of low density feedstocks, modeling simulation is very much essential to understand, to get insights about the phenomena. Process intensification through catalytic gasification, which is very essential to bring down the operating temperature. To again techniques to utilize bottom ash for value-added applications. Heat recovery, more efficient heat recovery systems to make it more economically attractive, environment friendly. And further, we are also conducting certain programs for development of even advanced gasifier, advanced dual bed gasifier. We can say again further version of this or advanced version, we can say. Coal and biomass ash utilization for variety of applications. Yes, it is essential. And CO2 recycling and utilization inside the gasifier as well as for other applications. So these are certain areas where we can work together. Csir-Cimfr along with other CSIR institutions, academic institutions and industries. So we can address certain aspects related to this particular area, and we make gasification more and more efficient, more and more user friendly. All these listed R&D related programs I am going to discuss in the scheduled conference at New Delhi on 20th October of this month. So all are requested to kindly attend this conference and my presentation there. And now finally, hearty thanks to all the involved stakeholders and agencies, including CSR, DG, for their support and encouragement, management from CSIR, directors from all the directors from Csir-Cimfr, and all of the entire management for their kind support. I'm remembering Dr. Bidi Kulkarni sir for its kind support and encouragement to us. Definitely vendor Messrs. Amar Equipment and their team, and their all the sub vendors also. Our gasification and catalysis research group and members, all the members, project associates, assistants, and our job contract workers, all the engineering service departments from Csir-Cimfr, purchase, account, administration, stores, and all the committees linked with this project, TNPC, TSCs, RC Research Council members who also encouraged us for this particular activity, specifically our mentor, and he was RC member, Dr. T. Mukherjee sir from Tata, Jamshedpur. Definitely Niti Ayog and specifically Saraswat sir, who was heading methanol economy. He's heading methanol economy program, mission program, task forces, Ministry of Coal and CIL officials, definitely CSIR, IPU for support in patenting and copyright related activities, several local service providers, peers and well-wishers. So thus I am concluding my experience with the thoughts from Einstein. Thank you very much.
You're welcome, Dr. Chavan. So it was a very elucidating lecture on journey of fluidized bed gas gasification facility developed at Csir-Cimfr. And Dr. Chavan spoke at length about the required procedure for creation of facility of coal well gasification at Cimfr Dhanbad, and all the administrative procedures that were adopted, the purchase and the EOI and all those things, the process which was required to establish and a center of excellence of coal gasification as is projected in the slide was established at Cimfr due to his effort, along with the effort of his team, I'm sure. And before we proceed to question answer session, there are a few questions that come to mind directly, because you talked about coal gasification and coal gasification process for generation of syngas. Two or three questions I would like to ask before I open the field for question answer session from other scientists and attendees, and that part will be taken up by Lipika, of course. But right now I'll ask you two or three questions which come to my mind. The first question that I'd like to ask is, I'll narrate my questions first, and then maybe two or three questions, and then you can take up, Dr. Chavan. So the first question is, why syngas production? Because the coal can be utilized as such. I understand. First, why production of syngas? What is the benefit, and what are the disadvantages of syngas production? Second is, I understand syngas contains a mixture of gases which contains not only, hydrogen and methanol, methane, but also carbon monoxide and carbon dioxide and other components also in small amounts, trace amounts. And the process of production of syngas requires a very high, it seems to be a very high energy intensive process. So while we are using it for production of energy, that is conversion of syngas to electricity, mostly electricity. From what I understand, the power plants that you spoke about in the industry, JSPL, Reliance, Talcher fertilizer, maybe Talcher fertilizer could be for fertilizer. I'm not sure about that, why the process was used. L&T and all they have that you have mentioned in your slide. So, and the process, the JSPL plant at Angul that you had spoken of, and I understand that that is for electricity generation from coal converted to syngas, and then so why it and how efficient and why are we doing it for gasification? Second is the same technology and same plant as you talked about agricultural waste and biomass for use of coal gas, for use of gas, to generate syngas from biomass. So the same plant, if you say it is a plant that was, the as the patent that you spoke of, I have not gone through that patent though, but I understand that the patent was for production of for this technology. So was the technology the same for and the plant design was same for uh, coal to syngas and biomass to syngas? Were there any differences in the plant design and how the process was there? And were there any efficiency issues regarding that? So, Dr. Chavan?
Yes, yes. Thank you, madam. First question was related to why we are going for syngas, why we are
Yes.
not utilizing coal directly. So
Yes,
since
yes.
gasification requires definitely, since it is a process, so certain energy requirement will be there. It will consume gasification step itself will consume certain amount of
Yeah,
energy.
some yeah,
Fuel.
as I read, it is
Yes,
around 1400 to 2000 degrees centigrade that you are raising the temperature, and that temperature will require some energy, consumption for having heating at that temperature. So
definitely.
that that
Yes, yes.
that is what.
Yes. So 1400 to 2000 is maintained in other type of gasifiers, entrain flow gasifier. That is
Okay.
different, which we are seeing in the these readily available gasifiers are there. Left side one. So ours is operated up to 1050 degrees Celsius. Fluidized bed. Generally, fluidized bed gasifiers are operated below 1100 degrees Celsius temperature. Definitely. Still, it is 1000 degree means not a lower temperature. It will definitely require energy. But major difference is when we talk about direct utilization of coal. Yes, we can utilize coal, but only for power generation in the power plants by combusting and utilizing heat. One can generate steam and then steam driven turbine and power can be generated. But when we target applications like methanol, fertilizer, steel industry, hydrogen generation, thermal applications, and other variety of chemicals, because syngas is we can say culprit. Once we generate syngas, several applications are there. through which we can eliminate use of petroleum products, use of natural gas, which is not available. If it is available, nobody will go for coal, definitely. But since India is, we do not have that type of resources, petroleum or natural, or we can say very limited resources. And coal is abundantly available. So we are converting coal to syngas, and further syngas can be utilized to fulfill all the requirements which we are currently fulfilling either through petroleum crude or natural gas or importing certain chemicals from other countries. So target of gasification is to fulfill other requirements, not only power. Power is co-generated utilizing certain amount of syngas or utilizing waste heats at different levels of gasification from different heat recovery power generation, we can say. And when if somebody targets power generation, only power generation through gasification, still it is efficiency point of view, it is comparable or more efficient than the thermal power plants. Another biggest advantage is related to CO2 capture. If we see the available power plants, generated carbon dioxide is very lean and quantity will be very huge. So capturing CO2 through existing power plants is very difficult. But in case of gasification, we get highly concentrated carbon dioxide. So capacity of the capturing facility will be on lower side, and one can capture even in proposed methanol syngas to methanol plant. We have CO2 capture and separation module. So CO2 capture point of view, definitely gasification will be required. When we target other applications like chemicals, fertilizer, methanol, liquid fuels, steel industry, direct combustion cannot work. Direct coal cannot be utilized for getting those products. Certain crude phenomena were there, certain even commercial scale phenomena were there in past, but worldwide people have stopped, denied those routes due to more stringent requirements, more harsh conditions and safety related aspects. So in current scenario, worldwide, gasification is the only route to get cleanest version from, we can say, dirtiest version. This is related to first question. Now coming to second question, it was disadvantages. Yes, related to comparison with biomass. So how we are conducting gasification of coal as well as biomass in same facility. Gasifier is common. Downstream things are modules are common, but feeder is different. For coal, we are using rotary feeder. Complete design is different for coal feeding because crushed coal is granular in nature. Density, its particle size, its other physical properties, sphericity, all other physical characteristics are quite different from the biomass. Biomass density, coal density is around 900 to 1000 kg per meter cube. Biomass density varies right from 150 kg, just 150 kg to maximum up to 500 kg for denser biomass, woody biomass we can say. So for handling this type of lighter biomass, we have screw feeder. Rotary feeder will not work there. So whenever we conduct gasification of biomass, we replace rotary feeder with screw feeder, and then we conduct gasification of biomass.
It would be in the same plant, but
it is in same plant. Reactor shell, gasifier shell is common. Operating conditions will be different. Velocities will be different depending upon their requirements. Means definitely density is on lower side. Means drag force required for fluidization, buoyancy force. All those things will be different. So velocity is different. Flow rates are different. carbon content and other hydrogen and other constituents are, its percentage, its composition is different. So required stoichiometric requirement is also different. Only shale, gasifier shale and downstream facility remains common. Once we convert it into syngas, then remaining facility, whether syngas is from coal or from biomass, doesn't matter. But feeding section is different for both these feedstocks.
And you can generate hydrogen also from the same process,
yes,
from biomass also.
Yes, from both these, yes, we have shown here.
But has that been used in any industry in India for hydrogen generation?
Yeah, because here we can see with coal we get 25 to 30% hydrogen as well as CO. But in case of biomass, since capacity goes down due to lower density, so we are getting CO, we are getting in the range of 25, but hydrogen is just 10% in existing facility. But if we definitely we have limitations related to capacity. If we enhance capacity, specifically keeping in mind the biomass related densities, simply we can say, one can understand easily, if we try to utilize lean fuel, say CNG or we can say even syngas in IC engine vehicles or any application for power generation in IC engine I am talking. So in that case, capacity of the particular IC engine goes down to its 1/4 of the original capacity what we get with diesel. So definitely with lean fuel, capacity will be on lower side. In case of biomass, we are getting lower capacity. So generated syngas is also is leaner than the what we are getting through coal. But since it is a test facility we are utilizing, means what? Suppose if we are intending to install commercial facility, say 2-meter diameter is required with coal, and we try to install same capacity gasifier for biomass, in that case the diameter will go above at least 2 times or more than that to get same capacity. I think I am trying to
give you the you are trying to give how the plant is modified to suit the capacity, or the the material which is the the raw material, whether it is coal or biomass, and depending on the capacity which is required for the from the plant perspective to run it to the maximum efficiency. This is what I this is what I understand. So what I'll do is you have been very illustrative about this, and there is a question hand raised by Dr. Nagaya. But
another one you raised a query related to JSPL. So JSPL is also, that facility is also not for power generation. They are utilizing syngas for steel industry for reduction of iron ore to get steel. And Reliance is utilizing hydrogen for refinery and certain amount to fulfill the captive requirements related to power. They are utilizing gasification. Target is not to generate.
But it is actually required for, even if it is for not for direct power generation, it is giving power to those plants. So if it is not power generation per se, you say if it is for the generation of steel or for generation of, for their plant, Reliance for generation of which plant that you said, refinery plant or whichever Reliance I did.
Refinery for getting other products.
For running of those plants, if they are utilizing syngas generated through biomass or through coal or whatever process, but it is actually giving power to that industry. So they are not using then electricity generated, or it might not be going, the electricity might not be going to the grid for that matter, but it is going towards the plant. And that is in fact a form of power which is being utilized for powering those plants that it is being utilized, if I understand correctly, that if they are
Yes,
running
yes.
on, yes, so it is
Another
anyhow, it is
important.
not, it is not powering the domestic system, but it is powering the industrial system, wherein the products, industrial products are being generated. So
Yes, yes.
so anyhow,
Another one important aspect is to get maximum outcome from the gasification. Always end product should be polygeneration. We have not discussed it is not in the scope of this today's discussion, but if we go for only single product, say any single product, very quickly I will share one example. If we go for say fertilizer plant, for gasification we generate oxygen, so readily available nitrogen is there. Nitrogen will be byproduct. Once we treat the generated syngas for separation of carbon dioxide will be there. That's why fertilizer plant becomes more attractive, because both these streams, carbon dioxide as well as nitrogen,
nitrogen, yes,
gets utilized for ammonia production and urea
ammonia
production.
production, urea,
So in
yes, yes,
this way, if we go for polygeneration, then maximum, including waste heat, waste streams, waste products, if we utilize judiciously, then this becomes very efficient, very economically, very attractive.
yeah. So we will open the field for question answer session, and Dr. Nagaya, you can come into that, and I'll give the forum to, not podium, to Dr. Lipika. She will take the question answer sessions, and let us have it from all the audience.
Thank you, ma'am.
Yeah.
Thank you, Dr. Chavan, for this very interesting and enlightening talk on the journey of fluidized bed gasification facilities developed at Csir-Cimfr. You have provided very interesting insights into the development of indigenous gasification, starting from identification of stock material, feedstock, establishing SOPs linked to those the characteristics of the feedstock, how you have developed the characterization matrix, and how you have proceeded from gas blown to oxy blown fluidized bed gasifiers. You have also provided us an insight how you have faced the challenges on vendor selection, challenges on fabrication, installation, and commissioning of the plant. So the insights provided by you are really remarkable, and they have provided us with understanding of this particular field, and also the different innovative possibilities in this particular field. So this floor is now open for question answer session. The participants are requested to raise their hands, and once called upon, please introduce yourself and proceed with your questions. And you can also provide questions in the chat box, which I'll be putting through to the speaker. Your questions, please.
Namaste,
I think Dr. Nagaya has, yes, sir.
Namaste, madam. Namaste, madam. Good morning, Dr. Prakash ji.
Good morning. Good morning.
You presented very nice and excellent presentation.
Thank you.
And madam also asked a very lengthy question for this both. The time is enough for the further discussions and all these things. But I am a layman about this coal gasification, because the CSR, ICT also some our colleagues are doing. But I want, you are really, this is a very good point. The Indian government also showing interest. But by your presentation, what I came to know, you have faced a very lot of problems, especially why our CSR is not encouraging this type of the project for country need. So I don't know, but you raised for COVID-19 is maybe what is exactly present status and what is the progress of the last 7 or 8 years? I don't know, the 10 years old project.
No. This is in 2020. This December 2020 we completed and dedicated this facility to nation. So since the last 2 years we are testing variety of feedstocks, other coals, other biomass and their blends, and we are utilizing this. This is the third project in this facility, apart from the project in which we developed this facility. After that we completed one project, and now we are continuing third project in this facility.
My question is not started. Because it is required for coal gasification, syngas purification, methanol synthesis, and methanol purification. But
Yes.
in your presentation, I have not got for the how your people are syngas are purifying for the sulfur and all these things, and methanol, who is making the catalyst and all these things in your mission mode project. This little is not highlighted than the presentation. Coming to the most important.
Can I answer this question first?
Yes.
Can I answer this first question?
Yes, sir. Yes, sir.
Yes. We have not included that part because we are in the progress of another parallel activity, syngas to methanol, which consists of syngas ultra purification, water gas shift reaction, CO2 removal to get hydrogen CO, desired hydrogen CO ratio, then modified syngas to methanol production. We are in the process of development of pilot plant integrated with this discussed gasifier. Presently, we have developed catalyst in-house at the Csir-Cimfr. Our group is working on that. We have achieved desired hydrogen CO ratio through water gas shift reaction and CO2 removal by amine-based separation technique. We have bench scale units for all the downstream modules, but today's discussion was targeted for journey related to gasifier development. That's why we have not included that part. Even a group from IICT Hyderabad has visited a couple of times here for discussions related to that domain, related to syngas to methanol and other products, even from scientists from other institutions, NCL, IIP, from certain activities from CGCRI, from CMERI Durgapur, from even from NML Jamshedpur, IIMT. So that downstream program is in process, but we have not discussed in today's lecture.
Okay. Most important thing, because why I'm involved in the biodiversity board discussions. So my concern is the last final question is coal to methanol process can have the environmental concern implications. So the implicable of the technology to reduce emissions and environmental impact. So how your people source? I'm not clear about your presentation. Just elaborate it, please.
Gasification itself is the cleanest technology to utilize feedstock like coal. Why? Because efficiency point of view, it is superior than other competing processes. Another thing, we get concentrated.
Yeah, we will like Dr. Venugopal to please switch off his mic. We will take the questions when we come to you. Let Dr. Chavan answer the question to Dr. Nagaya, and then we'll take your question. Dr. Venugopal, can you please switch off your mic? It is getting disturbing.
Another important aspect is carbon dioxide. So gasification have tremendous advantages related to capture of carbon dioxide. We are separating carbon dioxide. We can remove complete carbon dioxide from the product stream. We are removing at bench scale to get up to 75-80% hydrogen in the available facility. Still, we are using PSA-based oxygen generator, not cryogenic oxygen generator. Through PSA-based oxygen generator, we are getting maximum oxygen purity up to 90 to 93%. Means around 8% nitrogen is there, which is reflecting in our product even after removal of complete carbon dioxide. Still, we are getting around 75% hydrogen concentration at the downstream. So sometime in future we can discuss or even we can discuss through VC specifically with IICT group in near future, definitely. So gasification itself is a cleanest process where we can separate carbon dioxide. Efficiency point of view, it is attractive, and it can accommodate variety of feedstocks, including coal, petcoke, biomass, waste streams from several areas, including waste from industries, municipal solid waste, Only thing is depending upon the feedstock characteristics, means physical appearance, physical properties, type of gasifier will be different, and we need to develop operational philosophy suitable for that feedstock. So gasification as such phenomena is cleanest phenomena. It is adopted worldwide as a cleanest route for any to utilize any feedstock. I think I have answered. You are muted. You are muted.
Only thing because practical experience when I visited the many of these bio-based things which are our CSR is highlighting. Especially for CSR highlighting, because there is a purification process involved. But purification process is, I think, we have to, we means our scientific community to concentrate on the, especially for the, when we are taking the biomass of the vegetable waste and all these things. The concept, the way of the presentation of our technology to the concerned people is very neat and fine. But the characterization part is most important. That is only my sincere, humble advice for the who are working in this area.
You are 100% correct. That's why in the initially itself we have highlighted the aspects related to understanding of feedstock. We developed a thorough characterization matrix. We need to understand each and every aspect related to physicochemical characteristics of the feedstock, means collimatter or biomass matter, as well as mineral matter inside that particular resource. So both these understanding is very much essential to overcome operational issues, because all these impurities, all these foreign constituents create a lot of problems inside in the gasifier during operation also. And definitely at the environment point of view also. So thorough understanding related to feedstock characteristics is essential, and definitely value added applications of the bottom ash generated streams, waste streams, through environment friendly manner route is essential.
Thank you. Thank you very much.
Thank you very much. Thank you.
Yeah.
We have another hand raised from IICT. Dr. Venugopal, please.
Yeah. Good morning, everyone. Myself, Venugopal,
Good
working
morning.
in
Good morning.
catalysis department. My area of research is syngas to methanol DME, and we have been working on development of catalysts for the last 6 years under CSR project. Let me first congratulate Dr. Chavan's efforts in bringing out this pilot
Thank you,
plan
sir.
on coal gasification. And we have heard you many times on many forums, the efforts of Csir-Cimfr Dhanbad. I have, if you remember, I have sent 1 kg of catalyst just to test at your end. The optimized catalyst I have sent you, where to check the methanol synthesis activity. Referring back to, that's my first question. And referring back to Dr. Nagaya's query, you don't need to go for purification or removal of CO2. There are technologies where the crude syngas, which consists of CO, hydrogen, CO2, methane, and other traces of H2S, can be converted to methanol or DME in a single step. There are systems and established plants are running in and around China. That's the first thing. And you will not have any impurities, kind of sulfur nitrogen based compounds in syngas, which is generated from biomass. That is a clarification to Dr. Nagaya. And did you check, Dr. Chavan, did you check the activity of catalyst, which I sent you, 1 kg of catalyst I have sent you in pellet form last year, July? For methanol or DME synthesis?
Venugopal sir, to whom you have sent? We have not received. Our group is here. Dr. Csir-Cimfr Datta and his group is here with us. So to whom you have sent?
On your name. It is Dr. P.D. Chavan only I have sent.
But we have not
that was
received.
The 22nd.
I like to
Fifth-
intervene
fifth
right.
will be-
I like to intervene at this moment, Dr. Venugopal and Dr. Chavan. If there is a personal interaction regarding your research, I would like you to take it offline. We are
Yes,
here to
we will
sure.
discuss later on.
yeah,
We will
yeah.
discuss.
But if there are any questions regarding the present context topic that has been presented today, we would like you to please go ahead with your question and discuss whatever our queries are. But any personal or any scientific interaction between the two teams per se can be taken offline, please. Thank you.
Okay, okay, thank you.
We have another hand raised from IMMT, Dr. Verma. Please continue.
Yeah. Good morning. Good afternoon to all. This is Santosh
Good
Dev
afternoon.
Burma from IMT. Sir, we have been working in the areas of coal gasification since 2021. Me and my team, Dr. Rakesh Seni is also working with us. And we have been very closely working with GSPL, Angul. And now the thing is that very frequently they used to call us, and they come with the problem that the highest coal, earlier they used to use the Mozambique coal, which is actually being like, it is owned by the JSPL, therefore there is no import cost. But recently they have started using the coal of the Talcher region. And they are very frequently coming with the problem that when they are using the coal for the high media dense separation on a magnetite based solutions, the yield is very low. This is one of the problems they are frequently facing. And the design of the gasification is actually Chinese based company, Australian, South African, South African designs.
Lurgi,
Therefore,
Sasol Lurgi.
yeah. And recently also they have called us that they have a problem in the separation of the high media separation. So the Indian coal is very much not they are not comfortable with. They have to have like foreign coal having low ash, sometime something below 25% ash. But your case is 40%. Is it really feasible to use like 40% as 35% ash for the gasification in Indian context?
Yes, definitely. I will put this particular statement in reverse direction, because since we are having high ash containing coal, that's why we are developing fluidized bed. Otherwise, successfully commercialized, readily available technologies are available for low ash containing coal. If we do not have low ash containing coal much reserves, that's why we are developing fluidized bed. And fluidized bed is the technology. Definitely, it handles high ash coal without any issues. Since it is a low ash containing, a high ash containing, little but inferior syngas we will get when we compare it with low ash containing syngas from low ash containing coal. But this is the only technology to gasify high ash containing coal directly without requiring any washing.
Okay, sir.
Another issue what you have raised related to JSPL, their gasifier is low ash, requires low ash containing gas coal. They were using coal from their own mine at Mozambique. Now they have got mines in Talcher area. And you have highlighted the aspect related to washing, specifically washing related. Yes, definitely. You are also aware that Indian coal is drip to origin based generation.
Yes.
And other coal from other countries. So washing difficulty is there. I am not the right person. Experts are there. You may be knowing Uday Chattopadhyay from our coal preparation department. So he is the expert person. So you can get washing related queries, you can discuss with him. But yes, definitely, this gasifier handles high ash coal without any issue. That's why government's program, our program is to develop indigenous gasifier, which is suitable for high ash coal. Yes.
Yes. Sir, another question. Have you tried your gasification plant on the northeast coal? Because the hash content is around 2-3%, but the sulfur content is 2-4%. Have you tried on that? The fixed carbon is around 77%.
Yes, ash, sulfur content is not at all issue. Only thing is it should not have any caking property. Otherwise, inside fluidized bed, it will stick.
The swelling index is 2.
To remove sulfur, fluidized bed is again one of the best route. Why? Because we can add certain amount of dolomite and these type of things, and we can capture sulfur inside the bed itself, which will get removed from the along with the bottom ash. So even inside the fluidized bed gasifier, even if we utilize high sulfur containing feedstock, we can remove sulfur and take it out from the bottom ash, and we can minimize the sulfur removal load at the syngas processing or downstream facility. So it handles sulfur containing feedstock. Only thing is, what we observed, we have not tested northeast coal, but some coals from northeast area are having little but kicking nature.
Yes,
So
yes.
that we need to take care.
Sir, yeah, out of curiosity, sir, I have another question, because this gasification is a temperature intensive process. The syngas which is coming out, it has some heat. Can we recycle it back to the system where you are actually blowing air, so that the recovery of the we don't have to get that much heat, and the recovery of the yield which is not being converted can be again further increased? Is it possible, sir?
100% it is practiced in each and every gasification plant. People will not allow to waste single unit of waste heat to go into atmosphere. Since it is a pilot scale facility, that's why we have not made complications, and we are not utilizing. But in commercial plant, even in demo scale facility, maximum amount of heat will be recovered, and it will be utilized for preheating of all the input streams. So there will, so the net heat energy requirement of gasification island should not be more than 5% of the total energy input.
Thank you, sir. Thank you, sir. Sir, my colleague Dr. Rakesh also has one question, please, sir.
Sir, this is Rakesh Saini, senior scientist also working in the same area. So I have a question, like IIT Delhi, BHEL and other private company that is also working, and they have demonstrated recently this 1 ton methanol plant also. Because I came to know that also like the technologies from the Angul plant, they also visited. So they gone through their technology. So how different this technology, or like advanced version of this, or like they already have a more advanced version of this fluidized bed reactor? So is it the same, or there is some technical differences are there?
All these falls in the under the fluidized bed category only. BHL facility, Thermax facility, Csir-Cimfr facility, and also EIL. They are also having one facility. EIL R&D Gurgaon. But inside design details are little bit different. That's why performance is different, and major difference is in understanding of the feedstocks. Since Csir-Cimfr is a fuel research institute, port research institute, so we think that we know.
So one more last thing, like how we are continuously separating the ash particles, because they are getting fluidized. We know, like in the cyclone separator, we are separating, but this separation is not like 100% we are separating. So, like I was in Reliance also in the Jamnagar. I have worked there for 4 years in the anten bed reactor from Philips, so ConocoPhillips. So there the choking of the reactor is a big issue. So, but in the fluidized bed, I think it should not be there, because that's an anten bed. But how we are continuously separating the ash, because it will keep building, because we are putting 30-40% ash. So it should be continuously removed. Then only we can keep operating the fluidized bed reactor. So how will we make sure that it is getting removed continuously?
Yes, 100% true. It is a completely continuous feeding, continuous ash withdrawal facility. Okay, number one. And we need to maintain certain height of the bed inside the gasifier. Simultaneously, we need to feed fresh coal continuously, and continuous removal of the ash from the bottom side. And with this particular aspect, role of the distributor, role of the hydrodynamics inside the bed, and its effect on segregation of the ash particles and its removal from bottom side, it plays vital role. So in this facility, we are successfully separating ash particles to maximum extent, and we are getting 93% carbon conversion. It is the, we can say, most important aspect of fluidized bed. If we suppose people are facing issues related to entrainment, certain developers in India also facing, they are taking out maximum amount of ash from top side, from cyclone side. In that case, definitely they will face more issues related to choking of cyclone, then unconverted carbon from top side of the cyclone, of the gasifier. So we need to optimize the operating conditions. We need to design a distributor in such a way that we can provide maximum residence time for each and every particle, whole particle inside the bed, and get maximum conversion so that ash will be completely easily taken out from the bottom side.
Yes, sir. Thank you, sir. Thank you.
And
Yeah, thank you, sir.
related to issue in Reliance Gasifier, it is a ConocoPhillips gasifier. It is my completely personal thought. Their selection is wrong because pet coke, you are also aware, pet coke reactivity is very poor than
it's working
coal.
fine now. I think they have stabilized.
It is working, but as per my thinking, it should means for pet coke, high temperature entrant flow gasifier should be there than low temperature entrant flow. They are operating around 1450-1500 degrees Celsius in this range. And shell gasifier, air product gasifier, again it is in same category, entrant flow, but operating temperature is even above 1600 degrees Celsius. So it is best for pet coke type of thing. Another important aspect, if we try to feed, they need some either coal or ash along with pet coke in the entrant flow gasifier to make layer of the slag on the inside wall of the gasifier to protect that wall. This is a requirement in entrant flow gasifier, whether it is ConocoPhillips or Shell gasifier. And if we intend to use Indian coal, you can understand Indian coals are refractory. Ash is of refractory nature, having ash melting temperature again on higher side. In that case, how one can feed it in ConocoPhillips gasifier? They are facing issues due to, I think, due to little bit wrong selection. It should have higher operating range, even above 1600 degrees Celsius. They are operating, but again, they require certain amount of either imported coal or ash from imported coal only.
Okay, sir. Thank you, sir. Thank you for your insights.
Thank you.
There are a few more questions in the chat box as well. One is from Dr. Botre. CSR
do we have
CD.
Lipika, do we have time? Because we are running out of time, 12:30. Will the link continue? Otherwise, we'll proceed
Yes, it will continue. It will continue, ma'am.
It will
there
continue
are only 3
till
questions.
Yeah, then we can take them because 12:30 is coming to an. We have to have a vote of thanks also. But we can continue with a few more questions if the time is there. Yeah, please go ahead.
How have you handled challenges of precise process automation to achieve the desired efficiency of coal gasification and your solutions?
Yes, very much important aspect. Presently, we are using PLC SCADA system for its operation from the what we can say SCADA screen or remotely placed control console. We have to control consoles. And for gasification, like complicated thing, there should be complete automation linked with characteristics and optimization related correlations, then modeling and simulation related correlations. Means it will be mixture of entire characterization, readily available correlations from modeling and simulation area, and optimized conditions. then and then only one can go for complete automation. Complete automation in the sense, just we need to switch on the gasifier. Gasifier automation system will take care of all the concerns, all the operational issues. It will optimize all the parameters. It will take care. It will maintain all the bed height, temperature, feed rate, ash withdrawal, everything automatically. For that, a lot of things we need to develop. I have already identified those in our futuristic R&D areas, where different groups, modeling simulation related group, further mineral matter understanding, mineralogy related group, all those groups we need to engage. Presently, we are operating with our, we can say with through PLC, but in manual mode, not in auto mode, completely auto mode. Because we understand feedstock, we observe, we analyze, we discuss, and then we operate, we manipulate the parameters after discussion. In this way, we are operating. We are not operating completely in auto mode. For that, lot of work is needed to make it completely automated plant. Yes, your concerns are correct, and it is essential for to make it user friendly, more user friendly.
Another question from CSIR needy, Dr. Gupta. Can other labs use the facility? For example, RDF material, etc.
Yes, definitely. But only thing is, since it is a fluidized bed facility, so material should be free flowing. It should be fluidizable. So kindly, because as such RDF, if we get it is lumpy material, so we need to convert it into granular form. It should be free flowing for feeding point of view, fluidization point of view.
Another question from Dr. Doble, IPU. How patent filing has helped in the technology development?
Yes, fortunately, Dr. Sujan Saha is one of the team member for this particular activity. So we were having a lot of interaction with IPU, experts from IPU, Sujan, and our group. And in that way, we refined required document to for smooth filing of the Indian patent as well as PCT patent also for both the systems. Directly discuss this particular today's discussed system, ABC, as well as one associated system is there, thermogrametric reactor, that we have not discussed today, but for that also we have filed patent and several copyrights also. So we got a lot of help from IPU to prepare the document, to refine the document, and to make it more relevant IP point of view, or certain, we can say, protocols and certain grammar is there for patent filing. So that type of help we got from IP.
Since there are no further questions, I would like
just
to
a minute. I wanted to ask you one question in continuation with the patent filing part. The technology developed actually was though the filing was done with IPU, did you get any technology transfer on this fluidized gas bed gasification facility? Did it help you for technology transfer, the patent that you got? And have you been able to, as we are saying that there are certain industries which have such systems, but is this fluidized gasification system been commissioned in any of the plants in India, or in developed from Csir-Cimfr? Has it been commissioned anywhere?
It is not commissioned anywhere, but we are discussion with industries like Tata, Jamshedpur. They are again trying to utilize washery reject. Washery reject is again coal, but we can say inferior quality stream from washeries. So that stream they are interested to gasify and utilize generated syngas, just like a JSPL is doing for steel making. So we are discussing with them to first step will be to gasify to evaluate the gasification performance of washery reject streams in the available facility, our facility. And if we get attractive results, desired gas composition, and all other performance related figures within acceptable range, then they can go forward for its implementation. This is one case. Another thing is already Niti Aayog had a program. We are in discussion with Coal India as well as other stakeholders. There should be consortium because CSIR laboratories, we have certain limitations. Engineering houses, involvement of engineering houses is very much essential. Last year, there was a series of discussions and brainstorming sessions at our science center, CSR Science Center at New Delhi, headed by or chaired by our ex-DG Mandesar, directors from Csir-Cimfr, IICT, NCL, and IIP, Anjan Racer, Leleser, and I from IICT also. But the target was to collaborate with BHL to take forward this development. But due to certain aspects, it could not materialize. And definitely some joint venture is essential. Alone CSIR laboratory, or we cannot take it forward. Contribution from industries, financial, we can say, as well as coal supply, feedstock supply, utilization, and engineering involvement is also essential. We can share this development in the form of basic engineering package, and we can act as a knowledge partner during detailed design, fabrication design, mechanical design, execution of facility, fabrication of facility, during operation, during establishing smooth operation, operational philosophy, each and every stage. Being a scientific expert, we can contribute as a knowledge partner, and this can be taken forward.
One last question would be, have you processed this technology for expression of interest? Like, I am aware that some of the technologies from Csir-Cimfr were taken up with industry in the stream of, by the way of expression of interest. And so have you been, has this technology been under that format that you have invited expression of interest to collaborate with industry for further development and technology transfer, if there are any players available in the field who would like to work and contribute in that field with Csir-Cimfr?
Yes. Already we have prepared that document, and we have submitted to our technology marketing cell at CSIR.
Business development.
We are expecting it will be very soon. It will be published to call the expression of interest from various industries.
Yeah, that is a very congratulatory statement that you have said, that you are going to build that process to invite industries to further take up this work along with the Csir-Cimfr scientists. So yeah.
Since there are no further questions, I would like to thank all the participants for their very active participation, and the speaker for very aptly and elaborately answering the questions. Now I request my colleague, Dr. Ajayta, to offer the vote of thanks.
Thank you, Dr. Lipika. Good afternoon, everyone. On behalf of IPU, I would like to extend my sincere thanks to our DG Ma'am, Dr. N. Kalai Selvi, for providing her immense support for organizing this lecture series. Our humble thanks to the Csir-Cimfr Director, Professor Arvind Kumar Mishra, for nominating Dr. Prakash Chavan for today's lecture. Our sincere thanks to our head IPU, Dr. Vibha Malhotra Sahani Ma'am, for constantly encouraging us for organizing such programs. On behalf of CSIR family, I extend a special thank to the guest of the day, Dr. Prakash V. Chavan, Chief Scientist from Csir-Cimfr, Dhanbad, for being here with us today. Your thought and journey will surely going to inspire all of us, sir. Thank you so much, sir. I would like to thank all of you present here for attending this lecture and helping us to make this lecture series on innovation and IPR management a great success. I would also like to thank our SCDD team and IT team for the support and the wide coverage of this series. Thanks to all of you.
Thank you very much for giving us opportunity to share our experience and
Yeah.
to make this development more well known and popular in the scientific community.
Yeah.
Okay,
Thank
madam.
you.
Thank you.
Thank you.
Thank-
Thank you. Until the next lecture in November, we take your leave and we will come back with another technology which is going to blow the mind of all the scientists who are attending the lecture. Thank you all for attending. Yeah.